That's what we're going to get to. We're going to get to the possible rational zeros, but I feel like I need to just refresh real quick on how we're using this remainder theorem and factor theorem to actually factor these polynomials fully. So let's say, all right, so I'm going to say factor completely. And then we'll do PRZs. Let's say, let me think of one that's going to factor well. 2, 8, 5, and 3. Let's say that I have this polynomial f of x equals 3x to the third plus 4x squared minus 5x minus 2. And I asked you to find all the zeros for that polynomial, okay? The first thing you always want to do when you find zeros is to do what? Try and do what? Factor. You want to try and factor and get the pieces to set equal to 0. Well, can you factor that? No, you can't factor that, right? What if, though, I give you a factor? What if I said that x minus 1 is a factor? Find all the zeros. Could you do it then? Possibly. What could we do? If we have one factor, what can we do to find the other factors? Divide it, right? When we divide by a factor, we get a factor. Remember that 6 divided by 3 is 2? 3 and 2 are factors. So what we can do, divide by the factor. Okay? Can I use synthetic here? Why? It's not x squared. There's not a coefficient on x. It's just x minus a number. So I'm going to set it up for synthetic with a 1. So I get 3. And I feel like we talked about this a little bit on Friday, but just to refresh. So we drop, multiply, add, multiply. What should I get at the end if it's a factor? 0. Because factor means it has a remainder of 0. Okay. So now put your two factors together and what does it look like? I'm going to say put. That's exactly right. 3x squared plus 7x plus 2. And you want to multiply it by that factor that you divided by. Now remember, what did I ask you to do in the first place? Factor completely and what? Find the zeros. Now when we look at this, can you continue to factor? Is it factored completely, in other words? No. What do you notice? You can factor that again, right? That's a quadratic. We should be quadratic factoring pros. How do you factor a quadratic? Multiply A and C together. What's 3 times 2? Then you find that's exactly right. So what multiplies to 6 but adds to 7? 1 and 6. That's exactly right. So I have 3x squared plus 1x plus 6x plus 2. Keep this x minus 1, but don't worry about it right now. It's just a factor sitting in the problem. Okay? What's the GCF of 3x squared and 1x? X. What's left? What's the GCF of the last two? 2. And what's left? Remember, this x minus 1 is still here. It's still a part of the problem. We're just not working with it just yet. So factored completely, what does this look like? X plus 2, 3x plus 1, and x minus 1. Can we all agree that that is now factored completely? Yes. So how do I find the zeros once it's factored completely? Set it equal to 0. Set each one of them equal to 0. Equal to 0 and solve. Give me 1 0.
2.
Close. Negative 2. Give me another one. Negative 1/3, and then somebody said 1. The number of factors there is how many zeros I have, unless, of course, it's a quadratic. Yes, no, maybe so?
Yeah.
Okay. What if instead of giving you a factor, realize that if I gave you a 0 instead of a factor, I'm really still giving you a factor, right? Because if I told you, if I started this problem again, giving you this, if I told you that one of the zeros was x equals 1, then you would know that the factor is x minus 1. Remember, that's what we did on Friday with those factor theorems. Okay, if it's a 0, it's also a factor. It's x minus the 0 is a factor. All right, so let's talk about if they don't give us any of that. So I got 2 big things to get through: possible rational zeros, and then one other thing when we write equations that I want to talk about. Possible. So what happens if they don't give us a factor to start with or a 0 to start with? We have to come up with them on our own, and we have to test them, okay? So here's how we come up with them on our own. If we have this polynomial, let's say we'll take that same one that we just did because it doesn't have a whole lot. Be an easy first example. And let's say I didn't have anywhere to start. I don't have any place to start. They don't give me a factor. They don't give me a 0, okay? What I'm going to do is I'm going to make a list of possibilities, ones that may or may not be a 0, and then I'm going to test them, and we're going to talk about how we test them. But to make that list of possibilities, what I do I call these PRZs, possible rational zeros. We take the leading coefficient and the constant. Those are the 2 we look at, okay? And we do every possible factor of the constant divided by every possible factor of the leading coefficient. Y'all probably, or you should have done this in Algebra 2. Do y'all remember doing this? I hope you did. I know my crew did. All right. What's the constant in this equation? 2. What are all the factors of 2? 1 and 2. Or negatives, you can do that. So what we do is we say plus or minus 1, plus or minus 2, right? Mm-hmm. How about the leading coefficient? What's the leading coefficient? 3. What are the factors of 3? All the possible factors of 3. That's right. That's it. 1 and 3, right? Plus or minus there, though. So what we do is we're going to make all the possible fractions we can, taking the numbers on the right and dividing them by the numbers on the left. The factors of the constant divided by the leading coefficient. So what I could do, I'm going to take all of these and I'm going to divide them by this. Then I'm going to take all these and I'm going to divide them by the 3. So 1 divided by 1 is 1. 1 divided by 3. Now I'm going to take the 2 and do the same thing. 2 divided by 1 and 2 divided by 3. Now that doesn't say that those are all zeros. That says, they might be. They might not be. Do you understand what we did there? So there's 8 of them all together. 1, 1/3, 2, and 2/3, and then all the negatives of those. So now see if you really understand. How could I test to see which one's a real 0? You plug them in. What would you need? What would you be looking for when you plug them in? If it equals 0 when you plug it in. It's definitely one way to do it. You could plug it in and see. What's another way you could do besides plugging in? Divide. And what are you looking for when you divide? 0 as a remainder, right? So let me show you and I know we've already worked through this one, but let me just show you the process here. What I would do, I generally start with 1, if 1 is there, and 1's always going to be there. And I will start and I will say, okay, if I divide it by 1, and actually let's start with -1 because I know 1's going to work. I'm going to show you what the process is. We encounter ones that won't work. Sometimes you'll have to try a lot of different ones before, and that's why you really want to know synthetic really well. Now, if you're faster at plugging in, plug in 3, -3, 1, -1, -6, 6, 4. Does that one work? So I can eliminate -1 from my list of zeros. Well, then try +1. It takes a little while. Does that one work? Yes. And so I stop there and I go, wait, I have one, right? I found one of the zeros. And if I have a 0, then I also have a what? A factor. So because this is a 0, that means x minus 1 is a factor. And now I can pick up the problem just like I did before. Now factor it completely given a factor. Does that make sense? I did it with -1, but because the remainder wasn't 0, it didn't work. So what you're doing is you're trying all of these until you get to one that has a 0. So I'll make you a little note so you have it in your notes. Let's say to find a 0, which is actually a factor, start dividing by your PRZs until you get to one with no remainder. Okay, the point you have no remainder, you found a 0. That's the whole point. Yeah. All right. Yeah, that's just, and now I'm going to work an example with you from start to finish. So you can see what it is we're doing. So what we'll do is we'll go through, at that point we'll pick up just like we did in the beginning. All right, so let me show you one, start to finish. This will be one from your homework. Let's see. So we are just going to find the zeros. I'm not giving you anything else. We're just finding the zeros. So where should I start? What should I do?
6.
What about the 6? Okay, so what you're doing is you're listing your PRZs, right? And you're exactly right. What are the factors of 6, Jackson?
1, 6, 2, 3.
So 1, 2, 3, 6. What are the factors of 2?
1 and 2 plus 1.
There you go. The easiest way I have found to list them is to just take all of these numbers, divide them by the first one here. Then take all these numbers, divide them by the second factor here. Take them all and keep dividing that way. That's the easiest way to find all the possibilities. You don't have to include repeats in this list. Okay? So, if I take all these and divide them by 1 first, they're just themselves, right? So I end up with 1, 2, 3, and 6. Now what? Now the 2. Divide them all by the 2. 1, go ahead. Yes, if you can. What's 2 divided by 2? 1. That's already on the list, so you don't need to do it again. 3 divided by 2? And 6 divided by 2. That's already on there, so you don't need to do it again. Everybody see what we did? All right. What if what? Somebody's fixing to say something. And there might be some that you do. You know what I would do if it was a calculator test? Or a calculator, if you could use your calculator, I would kind of cheat a little bit and graph it on the calculator to see where it crossed. And then, because I'm going to make you show your work where you found the right point, but to know the right test point to use would save you a lot of time. You see what I'm saying? Like if you looked at the graph and you saw, hey, it's crossing at 3, I would let 3 be my first test point. Just a smart way to use what you know to start testing. But we're going to pretend like we don't have any of that right now. What's wrong?
What numbers you divide by? Like, you know, you still got 1/2.
Uh-huh.
What numbers are you taking?
All right, so I took all of these and I divided them first by 1.
Okay.
Then I took all of these and divided them by 2. All right, so let's start testing. I always start with 1 because it's an easy test. Make sure you look for placeholders. Do we need placeholders here? No. All right, 2, 2, negative 1, negative 1, negative 5, negative 5. 1, does it work? Why?
It's not a 0.
It's not a 0. 0 is crucial. It is negative 1? Oh, it's not. I don't know what it is. I just picked this problem out. Watch this be one we have to do a million gazillion. Negative 2, negative 5, 5, 1. Uh-oh. It's not negative 1. Is that what it is? Has anybody found one yet?
No.
Have you? What all have you tried? All right, I'm going to skip 2 then if you've already tried it. 2, negative 4, negative 7, 4, nope. Let's try Chandler's 1/2. I don't think it's going to be that. That's going to be a, no, that's not going to work.
It's not gonna work.
Oh my goodness, has anybody found it yet?
Can we try
3?
3?
Let's
No,
see.
I think we try 3.
Let me show you a trick.
I got a question.
Yeah.
Is there a way that we could like do it the other way around and start with 0?
That's cheating.
And what?
And start with 0.
Cheating.
No, this is really the only way to test. This is the only really cheat that you can do, and I wouldn't really call it a cheat, Silas. You might have been right with your 3 over 2. It looks like it's 1.5 right there. So let's try 3 over 2. Did you see what I did? But did you see how I kind of shortcutted it? Had I looked at that to start with, if that had been the first thing that I'd done, I would have gone, okay, this is crossing at an odd value, but that looks like 1.5. I'm going to try 3 over 2 first. Does it work when you do it?
So we're gonna do it even?
Huh?
Even value?
What you mean even value?
Even 3 over 2 or negative?
Oh, positive.
Okay.
Yeah. Because the 0 keeps the same sign when you divide it. It's x minus the 0 is the factor. All right, so 2 would give me 3, would give me 0, would give me 0, would give me -4, which would give me -6, which would be 0. Well, look a there. Okay, so if you do it on your calculator, you'd see it. 3 over 2 times 2. 2 over 1, which would be 6 over 2, which is 3. Right? All right, -4, so 3 over 2 times 4 over 1, -12 over 2, which is -6. So we're not done. We did all that so we could find a factor, right? Right. You'll do it so much within the first couple problems, you won't forget. All right, look, x minus 3 over 2. Then what do I have? What is this?
You got 2x squared.
Plus 0x minus 4. Okay. Now remember, I got to factor completely because my whole goal is to find the zeros. Okay. So now it's downhill from here. What can you do here? Factor out what? 2. So if I take a 2 out, and I'm just going to put it in front of the whole problem. Now set everybody to 0 because I can't factor that x squared minus 2 any further. So here's 1 and here's another. There's 1 0. What happens here? Square root, and when you take a square root, what do?
You gotta square with the different.
Looking back at that graph real quick. Well, okay, we'll leave it right there for just a second. Tell me why. Tell me, what did we call this? We were finding PRZs, and what did PRZs stand for? Possible rational zeros. What kind of number is square root of 2? It's an irrational number. Okay. It's like pi. It goes on forever and ever and ever, and it doesn't have a pattern or repeat or stop. Okay, so that's why it's not in our list, and we never would have come to that. So 3 over 2 was the only thing we could have come to there. Does that make sense to everybody? These take a while, and these can be tough, but this encompasses everything. I used to tell Algebra 2, this is the one problem. I could give you this one problem on a test, and I could test you over a ton of Algebra 2 concepts with this one problem, because you have to be able to factor. You have to be able to, I mean, there's just so much in this one problem. All right?
So what you're telling us is that I just
No, I'm not telling you that. All right, everybody okay on that? Okay, let me pause and give you.